Check 1, 2, 3. Click, click, click. Okay, let us start. Can you type in the chat box? Why? Okay, I'll just get started. So I will just discuss this latest work of mine. This is a solar project in California. And then the one that they use here is sun power. The specific model is Maxion Maxion model. This one has 470 watts max power. So let me discuss just some details for some that who aren't familiar. So the efficiency now of solar panels is 22.3%. Well, before 2013, it's just 17%. Let's discuss the some items that you may encounter. So these are the existing items. Oh, these are the new PV array. So what do we mean when we say PV array? Uh, a number of individual panels electrically connected together. So series parallel, just to be exact. And then we have 18 inverters. So the model is Solar Edge 480 volts. It's Y connected. It's a 158 ampere. So we check the catalog. It's over here. It's three inverters. So that's why it's Y connected inside this one. So what do we say when it's Y connected? So let's check it out. Okay, simple as that. Just like the letter Y. So take note that if you have Y connection, you will produce another terminal which we call the neutral. In the, however, in the delta connection, there is no neutral. So basic electrical or not familiar. Okay, so take note. Oh, this is the brand for the mounting system, panel clock, North America. So the installation will be flat roof. So in order to estimate, you will need to have to be familiar also to some of the items. Mm, just have to read and search through the internet. If you do not know most of the stuff. So this is the solar panel. This one is the wind breaker. I remember correct. So these are the rails and they have clips. So this one, okay. This one. We have the rails, base, the bolts, wind deflector. Sorry for the earlier. That is the brand. However, what I did here is I have to make it visible. So there is This one is the PV module. Each color is each string. For example, string 128. This one here represents the wire. The module, here's the wire. This is the wire going to the inverter. And then this one is a wire also. It is a PV wire. Let's check. PV wire 10 gauge. Two 10 gauge wire plus 6 number 6 gauge wire. So how, you may ask, how did I come up with those um, items or some details? You just have to look it somewhere here. See, they have, with an electrical plan, when reading an electrical plan, there is always some wire schedule, especially if it's a big project. So DC1, this is the conduit type, the phase conductors, and the grounding conductors. So thank you for watching. We have two concurrent viewers. So let me discuss now the wire schedule for AC1. What is this used for? This one is 2-inch EMT conduit. It has inside the 2-inch conduit we have 3 number 3 over 0 plus neutral number 6 plus ground number 6. And then the AC2 3-inch conduit, we have 3 700 kc mil plus neutral and ground. So the example is this, the AC2 conduit detail. So we have 8 conduits with 5 wires. So we can see it also here. So you can see that we have, for example, this string 1 8.1. We have 28 panels. So this box, let me just, can we highlight this? Just highlight. This box is the terminal output for your solar panel. And then this one I will highlight in orange. Oops. This one is what we call the okay. I'm sorry for the disconnect. So as I'm saying, the ratio for PV per power conditioner is, or power optimizer, I'm sorry, is 1:2. So if you have 28, you will have 14 power optimizers. So what can we observe here? The connection is we have two. Okay, let's look up first this connector is called MC4 connectors. It's a standard connector. We can look up again here. These are your MC4 connectors. Go back there. Oops. Again, for those who are not familiar, I just named the file or the portion here or sheet as SLD because I don't want to type the whole word, the whole word single line diagram. Sometimes they call it power riser diagram. It's all the same. And then what we can notice to this connection is from panel to power optimizer, they connect in parallel. And then the output of the power optimizer, it has two, the positive and negative. So the positive goes directly to the DC disconnect before going to the inverter. And then the negative one is going to the positive one. So it's a series connected, parallel series, and then parallel again. So that's the pattern. And mind you, they have also grounded connection. So let's do not question the design. Let's just comply because we're just an estimator. If that's the job of estimator. If the design is wrong or questionable, however, if it's acceptable, uh, we can accept that. But if it's not acceptable, it's against the principles, fundamentals of electricity, or in essence, the installation will not work. So we have to raise our concerns, or we can correct through our estimation. We cannot correct the design, especially if it's a big project, because this is made by professional engineers. Okay, are we clear on that? So what I did here is I counted all the PV module per string, so I can check the quantities as per design. And then I just got what I did is I got this length in linear feet for the rail mounting and the wind deflector, plus the simplify how it looks. See, I already hide some items. So if I show that, imagine if I add more, what will it look for you or for the one who will check? So let's get back again. So this for the wiring. So this one is the wire for the solar panel. So you can see that I have two wires already, because regardless of the series parallel, if you count, one is going to the inverter, one is going back from the other end. So it's already two wires already. And then the home run is this one. So this is the inverter. So from the inverter, I just made this as spare because of course there will be uh, what you call this, bends and vertical considerations, but you cannot because it's just a 2D. It's just a 2D plan. You cannot bend, make lines. It will be very messy. And then what do we have for the feeder? For the main feeder, let me show you here. Okay, so here we have. Let us first check the detail. Mhm. So this is the elevation of main switchboard. This one is existing. So this one is the new PB switchboard. So to view the whole perspective, we have the site plan. So this is the rooftop. Okay, we have the simple legend. The square ones is the sun power modules. These ones are skylight. So we have the inverters plotted over here. So they will go the switch gear, which is here, and then from the PV switch gear they are going to the MBSC. Okay, so let us check the wire again as I mentioned before. So from the inverters going to the PV switch gear, this is the wire size AC1, and then this is the wire size for the AC2. I just made 8 sets. So it's not that hard actually. You just have to read items. It's much better to estimate rather than design. So that's it. So thank you for watching my live stream. I hope I hope you learned some of the viewers, and thank you. If you have any questions, just ask.